Hey everybody, welcome back. We're talking about conics. Specifically, we're talking about parabolas. There are other conics like ellipses and hyperbolas and circles. We're not dealing with them today. Let's review the definition of a parabola. It's the set of all points equidistant from a fixed point and a fixed line. Now keep in mind that point is not the vertex. That line is not the axis of symmetry. The point here is called the focus. It has some properties. They are this. Are these. It is inside the parabola. It does not touch the parabola. It is on the axis of symmetry there. The directrix is the line that we're talking about, and it is outside the parabola, does not touch the parabola, and is perpendicular to the axis of symmetry. It is this line right here. That was fun. That is a vertical parabola. It necessarily has a horizontal directrix. You should recognize that parabola as a function. That's not a function. It is a horizontal parabola. It necessarily has a vertical directrix. We use the idea of a parabola being a function as well as its lead coefficient here to identify this answer. So this is a function because it's x squared, negative lead coefficient. Keep in mind it's Socrative. If I ask for number 1, that's what I mean right there. Number 2, you want to isolate the linear variable and say x equals negative 3y squared plus 16. This is not a function because y is squared, and a negative lead coefficient makes the answer D. Pretty simple. Number 3, this is in transformational form, so I want to convert it today again to a familiar format. We don't really have to do this, but this is fun. So we distribute a 4 and square a binomial. We add 20 to both sides and divide both sides by 4. The lead coefficient is 1/4, and it's positive. Well, so is that. Those numbers are always positive together and negative together, so we really don't have to do that. So this is a function because x is squared, and it's positive lead coefficient. The answer is C. Number 4, AB right here is the focal length P. All right, P is 5, focal length. And EF is the focal width for P, and so it would be 20. That follows. P and 4P, width, length, and focal width. We are studying transformational form of a parabola today. There's old vertex form. You should recognize the vertex is 2, 5 with a lead coefficient of 4 and what all that stuff means. This is vertex form of this parabola because its vertex is the origin. And I want to show that A is equal to 1/4P. And I want to do that. You might want to pause the video and look at all the particulars of this thing, but I want to go ahead and say that this red segment right here by the distance formula is that. And this blue segment right here by the distance formula is that. Again, you might want to study that. Those two segments have to be equal by the definition of a parabola, which would give us this. Wow. And so if we squared both sides like that and then expanded the binomials, we'd get this. And then stuff cancels. I mean, that happens in math. The p squares, the y squares cancel, and then we would just have that left. Not much left. And then add the 2yp to both sides, we'd get x squared equals 4yp. And I want to divide both sides by 4p. And get this, that 1/4P is the lead coefficient now, where it was A. And so we can now say that A equals 1/4P, and we will say that. Let's say it here. Let's take vertex form and manipulate it. I want to move the K over. Everybody can do that. And then I want to divide both sides by A. Everybody can do that. Well, that's not mathematically pleasing, so let's please the mathematician by writing it like that. And we just learned that A equals 1/4P. Well, it follows that P equals 1/A. If you don't believe me, you'll have to call me or text me or something. We'll talk about it. And so if I take this here and substitute for 1/A 4P, I get what is called transformational form. A new form, kind of like the old form, but with some new stuff. All right, vertical and horizontal parabolas. We know that vertical parabolas are function, horizontal parabolas are not functions, and that's going to give us two different formats for our parabolas. A vertical format, which is a function, and a horizontal format, which is not a function. You don't really have to memorize that for now because I'm going to give it to you, and this is what I mean. All right, I think we have 3 of these. They take a little while to get through. So let's get through them. You may want to pause the video and graph what you see there. All right, I went ahead and graphed y equals 2. And let's see, the focus is 3, -6. So we graph that. And the vertex is going to be the midpoint of that line segment. Well, to get that, we really just have to do the midpoint of those two numbers. That. And that is -2. So the vertex, which is the most important point, is 3, -2. Let's write that down. And in fact, let's back up and say that. So at Socrative, if I ask for number 5A, what's the vertex? You have to put exactly that. No spaces, please. And then for 5B, let's do it here. Well, let's graph it. Here's the vertex here. The focus has to be on the inside, so it has to go down. So this is a function. So this one is not a function, and this one is a function. So let's get rid of that. And let's expand this and substitute. Well, P is this distance right here, which is clearly 4. So 4P is 16. And then y minus k, k is this number right here is the y coordinate of the vertex. So instead of doing y minus -2, let's do y plus 2. I mean, this is high school. Come on. And then x minus the x coordinate of the vertex is 3 squared. Now, I did this to make sure that I got it right. And I generally do this sometimes, that it's negative, and this parabola opens down. So we have to kind of remember to put the negative there. That's the only way you're really going to get that. So at Socrative, for 5B, we would type exactly that. No spaces, please. Let's move on. I think we have 2 more. Pause the video and see if you can graph what we have and see how far you can go with it. Hey, man, these are fun. All right, so we have a vertex. This is the most important point. And we have a focus. We know it goes that way. We want to be able to write the directrix for 6B. This length right here is 1, 2, 3, 4, 5, 6. So we'd have to repeat that length this way. 1, 2, 3, 4, 5, 6. And I believe we would be at 11. X equals 11. And so for 6A, what is the equation of the vertex? It's directrix, excuse me. It's X equals 11. And for the equation, we want to pick the one that's not a function. This one is not a function. That one is. So let's use this and let's substitute. P is this length right here, which is what we've already counted it. 2, 3, 4, 5, 6. So 4 times 6 is 24. X minus the x coordinate of the vertex, 5, equals y minus the y coordinate of the vertex squared. And then let's compare that to the answer. Keep in mind that you do have to observe the negative because this thing is going to the left. If you leave that negative off, you're going to miss that. And man, we'd be sad about that. 6B right there. We have one more and then we'd be done. All right. Again, pause the video. Graph what you can. See how far you can go. See if you can do 7A and 7B. All right, I have graphed the directrix. I have graphed the vertex, maybe. Yeah, there it is. So that would be 3, -2. Let's write that in. And then the focus is what we're trying to find. You repeat that distance right here, okay? And so we want to repeat it here. Well, that length is 7, so we've got to go 1, 2, 3, 4, 5, 6, 7. And that would be a total of 10. So this is the point 10, -2. And so that would be the answer to this, which is 10, -2. Coordinates of the focus. Let's finish this thing up. This is not a function because the vertex is here. It would graph out like that. And let's pick the non-functional format. We already know that P is 7. We just counted that. So 4 times 7 is 28. X minus the x coordinate of the vertex is 3 equals y minus the y coordinate, but it's minus -2, so let's put plus 2 squared. All right, let's check that with the answer to make sure we got it right. Looks like we did. Keep in mind it's positive this time because it's going to the right. Guys, that was so much fun. I look forward to doing more with these with you. All right, guys, I'll see you later.